All right, so this one, I suggest reading through it, trying it out. It can seem a little overwhelming because getting every palindrome within the string is like, it's a little, it might seem a little overbearing, but I still think it's worthwhile to run through a solution to this one. So we're going to go ahead and do so. Let's call it count substrings, pass it as our input. And basically what we're going to do is we're going to do a bit of a brute forcing method, but it's pretty, I like this method because it's very readable, and we can talk about how we could do one a little more efficient, but I think this one is pretty solid. So basically we're going to jump through each letter and say if its reverse is equal to it, then +1 to our count. And that's pretty much it. So I'll explain it a little more in a second, and we'll walk through how it works, but let's just code it real quick. Let's say let I equals 0. So standard for loop. I'll show you in a second why we're not using the ES6 type of one. So rather than saying for each character, we're going to have to use the index. We're going to say j equals I. So that's a little tricky, but basically as we go through every letter here, we want this one to increment each time our I does as well. So we don't keep starting from 0. We can start from 1 and then 2. That'll make more sense in just a second. So this is the main part. We want to say, so if this, let's take the first letter. If this first letter is equal to its reversed form, so the very opposite of it, then +1. So the way we're going to do that is we're going to use substring. We're going to say I, j +1. And I'm just going to cover this before I walk through how it works. I'm going to say if this part, so this substring, is equal to the substring in reverse. And how we reverse a string in JavaScript is we got to do this. So split it into an array. It seemed a little laborious, but that's the way it's got to be done. And that'll get us all the way there. And one way of making this, well, first of all, take a look at that. And it's a little lengthy, but it will work. Let me grab examples here or grab the inputs. Give us a little room. And just to show you. We want 3 there. No, we don't. We want 6. No, we want 3. 3 there. We want 6 there. And we want 6 again. So it works. And as you can see, it's just going to be jumping through and saying if that letter, so if that group of letters, let's take this, and let's take these 3. When we're here, we have that part of the substring. We get that part of the substring again, reverse it, so now we have BAA. If that's equal to AAB, so if it's a palindrome, add to our count. And since this is a little ugly, let's just throw it into a helper function for the part. Let's call it isPal. I think this is going to make it look a little nicer. And now all we have to do is say if is a palindrome and pass it in. Then add to our count. Oh, I missed. So as you can see, that works. Looks a little cleaner. And I'm just gonna walk through how it works. It might seem obvious to you at this point, but I think it's worth walking through because to me it's not so obvious, or it wasn't for a while. So let's say count is 0. Let's use input of A. Let's have and let's just jump right into it. So first time through, I is 0, j is 0. Now we get here. Yeah, so j is equal to I, which is 0. And we want this substring to be I and j plus 1. So what we're passing into the substring, so let's just leave it as j plus 1. So this is the very first time through, we have substring with indices 0 and 1, which, if you recall, substring works in such a way that the way I think about it is this second number gets cut off 1. So it's basically what we're going to get from our string is, so I would be here, j is here, and substring, the second number actually only goes 1 less than this indices. So I probably overcomplicated that a little bit, but basically all we're going to be getting back this first time around for substring is A. And when we pass that into is palindrome, A is equal to A, so now our count is 1. So after that, we go back here. J plus 1 is now going to be 2. Yeah, because we only go back to this part. And we increment j. So j was 1, and then we add 1 to it. So now j is 2. And we say so now substring I is going to be, so I is still here, j is now here. So our substring is going to be these two. So it's AA. We put it into is palindrome. We get true. So our count is now 2. And third time around, j gets incremented by 1 to 2. We do j plus 1 is what we want in our substring. So now j is 0, 1, 2, 3. So j is here. I is still here. And this part gets cut off, so now we have AAB as our substring. And AAB backwards is going to be BAA, so those aren't equal, so count's going to stay at 2. And finally, j is 3, but plus 1, j is 4. J is now here, but if we pass substring 4, this part gets cut off, and we just take the whole string and actually j with indices of 5 would point here. But yeah, anyway, we get the whole string. That is not a palindrome, so our helper function would return false, and we would be done with our first loop through. So now, after that, we get back to here. I is now 1. 1. J is now 1, because j equals I. And j plus 1 is 2. So what we pass in this substring is I is here. J is 0, 1, 2. Here. This gets cut off. We just pass in A. A is a palindrome. Increment. Do that again. Zero, 1, 2, 3. This put there. That is not a palindrome, so we stay at 3. This is 4. J is here. Cuts cut off. ABA is a palindrome. Boom. That loop's done. Because j is greater than j is now greater than s, the length of s. So I is 2, j is 2, but we add 1, and j is 3. So now I is here, j is here, substring is b, b is a palindrome, 5. Boom, boom, yay, not a palindrome. So, oops, that stays. These get reset. 3. And 0, 1, 2, 3, so I is here. J plus 1 is 4. String is A. Count is 6. And that is all. So I is now 4. J is 5. 0, 1, 2, 3. So yeah, this wouldn't even happen because I is greater than the length. Or actually, I is less than s dot length. Yeah, so it has to be less than the length. So this loop wouldn't happen this time around. And we would return our count, which is at 6. So hopefully walking through it makes sense. I know that seems repetitive, but you can see how that works. just to walk through one more example to see exactly what we want from this question. I think it helps to think about, because you can call it an edge case. Let's call it, so one of the classic palindromes, just to show you how that would work. So with race car, we would want every letter is going to be a palindrome of itself. So 1, 2, 3, 4, 5, 6, 7. So let's pretend our count is at 7. Now, this whole thing is palindrome. So 8. This is a palindrome. 9. And it helps to walk through this because at first I was like, wait, maybe this algorithm doesn't work. But as you can see, this would be the very last one. CDC, that's 10. And then if you recall, E has already been counted itself. So we get 10, and console like that, we do indeed get 10. So yeah, this algorithm works. It is O of n squared, because for every letter we're having to jump through the entire array again. All right, worst case, but so there is some fancier algorithms that can do it in a little more efficiently, but this one, in terms of readability, is pretty nice. And so I think it's as good or better than the other stuff you're going to find. Another way I saw of doing this in a little more efficiently, big O wise, would be to keep a counter here. And basically what it was doing was taking a letter and then looking to its left and looking to its right and seeing if that's an algorithm. If it was, then add 1. If it's not, then break out of that loop. So you can see that that would be a little more efficient because we don't have to necessarily go through all the way. If it's not a, so a good example would be this one. As soon as you get A, B, or AAB, we know that further along are not going to be palindromes as well. So we can break out of that and keep going to B. So a little more efficient, but a little less readable when you go to code that one. So I think this one does the job, and unless you're working with some really big strings, it should be all right. So yeah, I hope you found this video helpful, as always.